Hello everyone and welcome back to another video covering the OCR Computing GCSE course. We're following on directly from the last topic, which is all about binary logic. Please check out the last video if you haven't watched it already, because literally we're doing exam questions today and we're sort of moving on slightly with the topic from last video. So last video we looked at what binary is briefly, we also looked at different logic gates, but now we are combining them in circuits and testing out our knowledge with exam questions. So I'm going to go through 3 different exam questions from 3 different OCR papers, and here we have to combine some circuits and draw some circuits, which is very important because those are often worth a fair few marks. So unfortunately, the only negative hopefully in this video is that I'll be getting my graphics tablet out, which I'm notoriously bad at using because I have two monitors and it sort of stretches my writing a bit, so I have to write really small. Anyway, let's get straight into it. So the first question we're given, and this is from the January 2013 paper, it asks us to state the output of each of the following logic circuits for the inputs given. So first here it actually gives us, it tells us it's a NOT gate. So a NOT gate essentially does the inverse of our input. So the inverse is the same as the opposite. So the opposite of 0 is 1. I think that's fairly standard. The NOT gate's probably the simplest gate in my opinion. It just does the opposite of whatever it is. We can also work backwards. So if we got given 1, we could work backwards to 0. Here we have an AND gate, and this is true only if both are true. Oh, that writing is absolutely appalling. I do apologise. So this gate means that both inputs have to be true in order to the output to be true. So by the way, if you're a bit confused with me saying true when I'm talking about zeros and ones, yeah, you probably should watch the last video. But 0 is representing false, 1 is representing true. So the AND gate needs both to be true for it to output true, or only 1 is true, therefore it results in 0 being outputted. Okay, slightly more complicated now. We're going to fill in a truth table. So here we get a circuit diagram with actually 2 logic gates combined for this circuit. So we have a NOT gate here and an AND gate. So a NOT gate is actually one of the inputs. So you can see here written as the output sort of formula. It's a bit like algebra. You work out what's in the brackets first, not necessarily algebra, just maths basically. You need to work out what's in the brackets first, so we work out this input. So and then we work out the other input. But we do this from our truth table. So let's first fill in the gaps in our inputs. So there's only 4 possible combinations for these 2 outputs. The other one being Q being 1 and P being 0, and P being 1 and Q being 1 as well. And that fills in all the possible combinations, as we've got for binary 0 here, we've got 2, we've got 1, and we've got 3, which fills in all of our gaps. So our output here, we need to work through this bit logically, a bit of a puzzle. So here, first things first, like I say, we need to do what's in the brackets first. We've got to inverse this because this is a NOT gate. I input 0 and we need to inverse it. We need to inverse it to get our output. So the opposite of 0 is 1. So then we have 1 and 1 because we're on this little row. 1 and 1, and that means it results in 1 because, like I say, an AND gate's true only if both are true. So now you may well see where this is going. We've got to inverse this, so this will be inverse to 0, this is inverse to 1 like I mentioned before, and then it will be 0 and 1 as our AND gate, and that will result in 0, 0 because of not both of them aren't true. So here's the mark scheme if you don't believe me. Yeah, so it shows you here what you get your marks for. You will get you will get certain marks for your working sort of thing, or as you go along. Right, question number 2. It's very similar, in fact, almost identical first part to what we just did. It shows that there's only so many questions they're going to throw at you. So again, we have a NOT gate here and an AND gate. In this example, we don't actually tell you which one's which. You'd have to know this with prior knowledge. The other one was a bit kinder. They actually gave you which gate's which. So again, we're going to fill in a truth table. So we literally first things first, for A, I input A, we have to inverse it because it's a NOT gate. So if we just write it by the side, this would be what? Oops. Oh, that's rubbish. It would be 1 and 1 and 1 equals 1 as our output. Opposite of 1 is going to be 0. And 0 and 0, false and false equals false. Opposite of 1 is obviously 0. So opposite of true is false. And false and true equals false as well, because it's an AND gate. Both have to be true for it to be true. Everything else is false. So now we have to do something a bit more exciting. I mean, depending on how you look at it, we've got to draw a circuit diagram to represent not A and B. Right, I haven't actually looked at this before, so I probably should have a little think about it. So our output P, we need, first things first, we need to do what's in the brackets and then inverse it. So we need to draw a AND gate first. I'm looking at this for the first time, hence I'm being a little bit slow. Right, let's see if I can pull this off. Oh, no. That's absolutely appalling. Let me try that one more time. So we're going to draw an AND gate. If I can't quite manage it, you might have to bear it in mind. And then we draw our NOT gate. That should be slightly easier to draw, or just about. And then so our output's P, A and B. That is the worst logic diagram you ever see, but I think you'll find, if I'm correct, yes. So the mark scheme, yeah. So 1 0 0 and faintly drawn, same as mine, although a bit better, a bit neater. So yeah, you'll get your marks. You can also draw a NAND gate, I think. Maybe not, but that's not in your course, so it doesn't really matter. So another simple question. This is quite a nice one, I think. This is from June 2012, and we're simply filling in the gaps. So we first here have an OR gate. We haven't looked at OR gates in this video, we did in the last video. So an OR gate either can be true and it will result in true. We have a true and false, but the true is looked at here, so we get a resulting 1. Here we have a NOT gate, and here we've got to work backwards. So we do the inverse of, so something's been inversed to make false, and obviously that would be true. There's only 2 options here. Here we have an AND gate and a NOT gate. So this will result, 0 and 1 will result in 0 because both have to be true for it to be true, and then the inverse of 0 is going to be 1. Here we've got to work backwards again. We have an OR gate and a NOT gate. So work backwards from 0. Inverse of 0 is 1, and then so if this is 1, either of these 2 inputs has to be 1 for it to equal 1, and we've got a 0 already, so this must be 1, and the mark scheme goes along with this. So that covers this video. Very important that you understand what I've talked about. Some of it it makes a little some of it takes a while to understand, but it's worth persisting with, because this will get you a lot of marks in the exam if you understand. Anyway, thanks a lot for watching, and I hope to see you in the next video.